In this video, I'm going to go over selected problems from the Trig derivatives section, 2.3, 2.4, 2.5. So let's start with 53. We have 2x sine of x plus x squared cosine of x. We want to find y prime. And you should be able to see that we have two separate functions that are being multiplied. We have to go through the product rule. And again, two separate functions being multiplied. To apply to find a derivative, we got to go through a product rule there as well. So, apply product rule twice. Okay. So 2x becomes 2, sine x stays sine x, fg prime. So 2x stays 2, sine x turns into cosine x. Okay. Product rule for x squared cosine x as well, f prime g plus fg prime. So then f prime times g plus f times g prime. So cosine of x derivative is negative sine of x. Combine like terms, and we get y prime is equal to 2 sine of x plus 4 cosine of x minus x squared sine of x. Okay, 61. Evaluate the derivative at the given point. H of t is equal to secant of t over t at pi and negative 1 over pi. All right, if we're just trying to evaluate the derivative, we just need to find h prime, and then we plug in the t value, or in this case, the x value, or x or t value, into the derivative to evaluate it. So here I have a function over another function, so I'm going to go through quotient rule. Okay, so then I have f prime, secant of t's derivative is secant tangent, times g, minus f times g prime. So the derivative of t is 1, all over t squared. Okay. Once we have our derivative, then we can just evaluate the derivative by plugging in pi. So h prime of pi, secant pi tangent pi times pi minus secant pi over pi squared. Secant of pi is negative 1, tangent of pi is 0, and then secant of pi again is negative 1. So two negatives cancel out to be positive. So we're going to get 0 plus 1, which is 1, over pi squared. From section 2.4, let's look at number 55. F of t is equal to 3 secant squared of pi t minus 1. Find f prime of t. Okay. Whenever we see exponents, that is in the shorthand placement, we can go ahead and take that 2 and put it outside the function, just so that we can kind of get a better picture as to the chain rule that we have to apply. So I put the squared outside the secant function. So now we go through our derivative. Outside functions first. So the 2 comes down. So 3 times 2 secant of pi t minus 1. Okay. Raised to the first power, because we subtracted 1 from the original exponent. So now we've taken care of the outermost function's derivative. So now the next function in is secant. So the derivative of secant is secant of u times tangent of u. Okay. Notice that we don't change this pi t minus 1 because we haven't gotten to this derivative yet. Okay. Secant of u tangent of u. Now, after we've taken care of that, now we look inside the parentheses and we find the derivative there. So pi t, think of pi as just a constant, a leading coefficient in front of t, just like how you would treat it if it was 4t minus 1 or 5t minus 1. Right, 5t minus 1 becomes 5. So pi t minus 1 equals, or the derivative becomes pi. And then 1's a constant, so it goes to 0. And then finally, we can put it all under one fraction. 6 pi sine of pi t minus 1 over cosine cubed pi t minus 1. Okay, convert the secant squared to be 1 over cosine squared, and convert tangent to be sine over cosine. Okay, this is number 57 from section 2.4. Okay, so we want to find the derivative here. Now this exponent is only affecting the 2x. Okay? It's not affecting the entire sine function. So what I'm going to go ahead and do and is distribute this 2 through, so we can just get rid of one more layer of having to deal with that exponent out there. So I'm going to make it x to the 1/2, okay, convert it to exponential rational exponent, so that I can be in a position to find the derivative. 1/4 sine of 4x squared. I just distributed the exponent through. Okay, power rule here, derivative, 1/2 x to the negative 1/2. 1/4 is leading coefficient, it's going to stay. So the derivative of sine of u is simply cosine of u times u prime. So my u value is 4x squared, so therefore my derivative of 4x squared is going to be 8x. That's my u prime. And finally, 1/2 root x plus 2x cosine of 4x squared. Okay, 65. Find the derivative of a function at a given point. So we simply find the derivative and then plug in our x value into our derivative. Okay. 37 is a constant, so that will eventually go to 0. But we can rewrite the secant cube of 2x. Right? We can rewrite it as secant of 2x, all raised to the 3rd power. Find the derivative. 37 goes to 0. Bring down the 3, keep the bracket, subtract 1 from the exponent. Secant of u becomes secant of u tangent of u times u prime. And then we can put it, clean this up, make it negative 6 secant cube 2x, tangent 2x. So we found the derivative. Now we're going to evaluate the derivative at this given point. So the argument is 0, so plug in 0 for x. Secant of 0 is 1, and so we got to cube that 1, which will stay 1. Tangent of 0 is 0, so then negative 6 times 1 times 0 is 0. Okay, section 2.5, let's look at some problems dealing with implicit differentiation. Okay. Remember, we have to apply implicit differentiation whenever we see x and y's either mixed together or we have y's where the function is not explicitly defined. Okay, so sine of x, we find a derivative there. Sine becomes cosine. Cosine of 2y becomes negative sine of 2y, with the 2 staying as leading coefficient without changing. So the derivative of cosine of u is negative sine of u times u prime. But because we're involving a derivative for this variable y, we have to attach dy dx. And finally, on the other side, we don't want to forget constant. Its derivative will go to 0. So now we take steps to get the dy dx. All this is with my dy dx term. So I'm going to leave that on my left side, move the cosine over to the right side, divide both sides by negative 4 sine of 2y, and 2 negatives cancel out, so I'm left with cosine of 2x. Cosine of x divided by 4 sine of 2y. Okay, 13, sine of x equals x times 1 plus tangent of y. I'm going to go ahead and distribute that x through. So sine of x equals x plus x tangent of y. Here we can apply derivative rules here for sine x and for x, but here we got to be careful. We got to go through product rule for x and tangent y. Okay. Sine x becomes cosine, x becomes 1. F prime g plus f g prime is product rule. So 1 times tangent y plus x times secant squared of y. So tangent of y becomes secant squared of y times the derivative of, this is my u value. So the derivative of y is 1, but then we're involving y's derivative, so we have to attach dy dx. I'm going to leave this on the right side. There's already a positive value. So subtract 1 tangent y to the left side. And finally, solve for dy dx. Divide both sides by x secant squared of y. All right, 15. Y equals sine of xy. This is my u value that's inside my sine function. So we can go through our derivative rules. Y will go to 1, but we attach dy dx. Sine of xy, so sine of u becomes cosine of u times u prime. So the derivative of xy is what we need to do for u prime. But because we have two variables here, we got to go through product rule for the u prime. So f prime g plus f g prime. So f prime 1 times y plus x times dy dx. And dy dx is the derivative of y. Moving down, we can take this cosine of xy, distribute it through, so we can get this dy dx out of the parentheses. So y cosine of xy plus dy dx, x cosine xy. Take steps to get dy dx on the left side. So we subtract the dy dx, x cosine xy to the left side. Okay. And then finally, factor out dy dx, and then divide both sides by 1 minus x cosine xy. One final problem, number 27 from section 2.5. Find dy dx and evaluate derivative at a given point. So tangent of u becomes secant squared of u times u prime, so that's what we do here. Okay, so secant squared of u times u prime, so x becomes 1, y becomes dy dx. Okay, is equal to 1, because x turns into 1. And then we can take the secant squared x plus y, distribute through the bracket. So secant squared x plus y plus dy over dx, secant squared x plus y equals 1. We take steps to get the dy dx on the left side, move the secant squared x plus y to the right side, and finally we divide. So our derivative is 1 minus secant squared x plus y over secant squared of x plus y. So we have our derivative. Now we have to evaluate the derivative at a point. So we're now going to plug in 0, 0 into the derivative. Every x we see, we replace with 0. Every y we see, replace with 0. So secant squared of 0 is going to be 1. Secant squared of 0 is also 1, so 1 minus 1 over 1 is 0 over 1, or 0.